Right, so for those that are watching here, we left off, we had found A and B, these small letter A's and B's, and we said we could find out what these other ones were. So I'm just going to jot them down and work through it with you. So for B over here, my thinking for that is that if we've got y equals cos x in mind as a starting point, so we know that cos x kind of does that and it does that, and this lowest point over here is at negative 180 and it's at negative 1. So in this case, this cos graph that we've got, everything's moved right. Oh, I'm in front of everything here, doing really well. Everything's moved right by 45 degrees. So therefore, this kind of point here, if we drew this graph, kind of looks like that. That's the graph of y equals cos x minus 45 degrees. So which means that this point here, I've not drawn this really well to scale, but the idea is that it's moved right by 45. So therefore, instead of being at negative 180, we're just going to add 45 to give us negative, I don't know, I'm just not feeling confident here. Let me go here, minus 180 plus 45 minus 135. So therefore, our coordinates of B are minus 135 minus 1. So that is going to be my thinking of how I'd find out B. For C and F, as I said, we don't really have some good tools at the moment to solve that. So we could try some numbers here. And once we tried a few and kind of thought, well, it's probably going to be some sort of special angle, that sine of, maybe we kind of have the idea that sine of, should we start with this positive one here? Well, 45 is one of our answers. So sine of 90 is the same as cos of, where are we here? 135, no, of, well, sorry, sine of 45 and cos of 45 are the same. So, you know, we've got our 45 as one of our answers. And for these, as I said, we're just going to play with some ideas. And after playing with a few, I kind of got these as negative 75 and 165. So those were the two values I got where they were equal, of course, excluding this one that we were shown clearly. So that would be for C and F. For point D, well, that's 0. So I think the easiest way to do here is just to go, well, it's on the cos graph. So I'm just going to sub in 0 plus 45 and get root 2 over 2, 0,7. Again, you don't need the calculator for this because you could have gone, okay, well, it's cos, let's do it in blue here, but we're working out for, come on, we're working out point D over here. So for point D, we know that we've got cos of 0 plus 0 minus 45. Why do I have, it's going to be the same because cos of a negative is the same, but 0 minus 45, which is cos of negative 45, which is cos of 45, which you could draw a special triangle for, but that feels like a lot of rigmarole for getting root 2 over 2 when you could just put in the calculator. Okay, but it could be a non-calculator question. For point E, remember we said that for point E, we know that the y value is 0. We know that everything's moved right by 45, so we're going to do the same idea we did before, where if we're looking at our y equals cos x graph and everything's moved right by 45, so this intercept over here, well, over here we know that it would have been at 90, so therefore everything's moved right by 45, so this should be at 135. So that's how we could find that one, because it just moved right by 45. So that's for that. Now for the next example, obviously just rewind here to pause all of those. But for our next example here, similar idea where we need to find the values of A, B, C, and D. So let's just go through concept-wise and let's just maybe highlight that. So this is G of X here. That's not doing so well. Maybe it would help if I made it bigger than I can don't have to be as accurate, right? So there's our one graph. Okay, so that's g of x. And our other graph here is f of x. Wow, I missed the mark too much. This is harder than it looks. Okay, maybe I'll take a pause and a breather. Maybe you do better at drawing these. So there's that, and that looks like some sort of cos graph that's moved. And so there's our starting point. Okay, so for g of x, we've got sine dx plus c. So remember, d talks about our period. So our period here is, well, when we've gone from some sort of point here and we've started repeating ourselves, well, it looks like it's repeating itself every 180 degrees. Now, normally the sine graph repeats every 360 degrees. So therefore, everything's happening twice as quickly. Therefore, d is 2. Now, our c moves the graph up and down. Now, our sine graph would have started at 0, or started at 0 and gone to 0 and gone up to 1 and down to -1. Well, this now goes between 0 and 2. So therefore, it's clearly moved up by 1. So our c value must be 1. So for g of x, let's write g of x equals sine 2x plus 1. Now we can do the same thinking for our other graph, for our cos graph. Looks like it's moved left a little bit. And what are we told? We're told 60 and 0. So again, we've got our kind of our general cos graph in mind. It's been stretched. So let's start with the a value. I think that's normally easier. It looks like it's going, let's highlight some points here. It's going from 2 and it's going down to -2. So therefore our value of a must be 2, right? Everything's stretched out by 2. Doesn't look like it's been reflected because this graph, it's just been moved left by a smidgen. Oh, I must keep an eye on this. A equals 2, so we know that it's stretched by 2. Now, the cos graph would have had an intercept at 90 degrees. So if we were to just draw y equals cos x or y equals 2 cos x, would have had an intercept at 90 degrees. It's moved left by 30 degrees by the looks of it. So therefore, we can say that our value of b is 30, except it's -30 because it's moved left. So more importantly, forget the positive or negative. Can you write it in this form, which is cos x minus 30? And I'm actually lying onto it because it should be plus 30. This plus or minus always confused me because I always like to have a minus there because then it represents 30 is a shift one way or the other. So this is moved left by 30, which means it's a plus 30 above my head. Okay, so that's for the 30 degrees. Left by 30 means x plus 30, which means b is 30, but I'm used to a minus. Okay, so that's that. Now, if we wanted to take g of x, and g of x is our sine graph, and we reflected it across the x-axis, remember, whenever we do that for any function, it just means that we're going to make all the y values that were positive negative, and all the negative ones positive. So we're going to take the negative of the whole thing. So if we call this graph over here, I'm going to call this h of x, then h of x equals, well, we're going to take this graph and we're just going to make the whole thing negative. Sine 2x minus 1, because we've taken negative of the whole thing. So therefore, if we distribute that negative, we'll get minus sine x minus 1, because we've just reflected it, like a parabola or any other function we've done. Okay, and the last one here, I'm going to call this j of x. We're going to take g of x, the same one, and we're going to reflect it about the x-axis. So we're going to take this blue graph, and let's look at doing this in two ways. The one is just kind of thinking algebraically. Take all the x's and make them negative, or take all the negative x's and make them positive. So we're going to take the same function, and that was the sine graph. Yeah. we're going to take that sine graph and we're going to make that negative 2x plus 1. Wherever we saw an x, we made the x negative. That's one way of reflecting about the y-axis. And then we could say, well, what's sine of negative? Well, in this case, we know from our cast diagram or from our reductions that sine of a negative angle is negative sine of that angle, and the plus 1 is still plus 1. So that'll be one way of doing it, and probably a recommended way to do that. The other way would be to actually take this graph and say, well, this part is going to be at minus 135, and actually draw the graph. So you're going to go, instead of going here, it's going to go something like this. It would be nice if this other graph, because I don't want to get these values exact here. But so it's going to go, and it's going to go up, and then it's going to go down, and then it's going to go up. You can see why I said this is probably not the recommended way to do it. You could draw that reflection and then try and make sense of it. So no, let's go for option 1. Definitely seemed like the better one. And that is, we change all the x's to negative x's because that's going to reflect our graph. And that's how you can do it with any function, so why not do it here? Okay, so video, maybe useful, maybe not. Wonder if any of you are going to watch this or have watched this. If you have great stuff, let me know. But at least we've captured some of the thoughts in a very messy way on our worksheet over here. So, as always, remember to make a mess.